For example number 4, we're asked to graph a line segment. And one way to graph a line segment with parametric equation, it's easier because you could set the boundaries for t. Although I suppose with the Cartesian equation you could do the same thing. But again, the reason that we use parametric equations has absolutely, at least in calculus, it has nothing to do with setting the boundaries of t. It just, sometimes it's easier to take two variables and make them dependent on one single variable. That's a common practice. So what we're going to do is we're going to consider x equals 3t and then y equals 2 minus 2t, and then we're going to set the boundaries for t between 0 and 1. All right, and so if I graph this on my graphing calculator, it's going to look like this. Well, I like to write things out by hand, so let's do that too. So if I come in here and I make a table of values, and I have t, and I have x, and I have y. If I let t equal 0 and t equal 1, then my x value will be 3 times 0, which is 0, right? And then for the next value, if I let t equal 1, then the next value for x will be 3 times 1, which is 3. Now if I do the same thing for y, I'm going to get 2. And then for t equals 1, I'm going to get 2 minus 2, which would be 0, right? I'm just double checking that. And so I have 2 points. I have 0, 2, and I have 3, 0. And so if I'm to graph that on my graphing calculator, I get something like this. In fact, the textbook shows this is exactly what you would get. So you're going to have a y-intercept at 2. So this is the point 0, 2. And then you're going to have an x-intercept at the point 3, 0. And so that is pretty much the graph of the line segment. Okay, not that hard. I mean, you can plug it in your calculator, and I'll do it on the calculator in just a second. So now here's the part that I think you guys are struggling with on the homework, is it wants us to confirm algebraically. Okay. So now what I said in the part B on some of your homework problems, what they want you to do is to figure out what the Cartesian equation is. So by looking at this, looking at the graph, if I wanted to figure out the Cartesian, can you guys see that okay?
Yeah.
Okay. So I want something that's like y equals mx plus b. Well, we know the slope, which is m, and we know the y-intercept just by looking at the graph. Okay? So what is the slope? Well, in order to get from this point to this point, I had to go down 2, which was a negative 2, and then I had to go over 1, 2, 3. So I've got negative 2/3 x, and then the y-intercept occurs at 2. So this is what it should look like. Okay, so now how do I make it look like that? And let me change the color because I can't see that. So I should have y equals negative 2x, negative 2/3 x plus 2. That's what it should be. So now how do I verify that using the parametric equation? Well, the easy way to do it is I'm going to take this equation, x equals 3t, and solve for t. If I divide this by 3 on both sides, I get x over 3 equals t. So then if I go back to my original equation, so I'm getting this from the two equations. X equals 3t, y equals 2 minus 2t. So then what that means is that if y is equal to 2 minus 2t, then y is equal to 2 minus 2 times the quantity t, but we said that t is equal to x over 3. So I'm going to plug in x over 3 here, Now, if I clean that up, what is it? It's y equals negative 2/3 x plus 2. Is that right?
Oh, that's what I was trying to do, but I didn't think of
Now, the only time that doesn't work is when you have trig functions, because the trig functions, you could do it, but you have to be really good with the trig identities.
Oh, no, thank you.
And usually when they use a trig function, it's usually a conic section, like a circle or an ellipse or something. But that's pretty much it. Does anybody have any questions?